Okay, so here's the problem. Push pause if you want to read it. So here's the picture. If you're having trouble drawing this out, here's what the picture looks like. So we have our current going this way, okay? 3 microamps, that would be the current that we have moving in this direction. We have our proton here, and we want our proton to move in a straight line, okay? So there's going to be some kind of equilibrium, some kind of balance in the problem. So the first question says, find the magnitude and direction of the B field 2 centimeters above. So this is just simply going to be using the equation to find the magnitude. So the concept is we have our current going this way. Let's just find the direction right now. So your thumb should be following the current. Okay. When I curl through my paper and back around, what direction is my fingers moving at the location of the proton? Out. So the answer to the direction is coming out. Okay, that means there's a B field. Oops, not that way. This way coming out, right? So we could draw it with little dots showing that at that location it's moving out. So to find the value of it, we're just going to use our equation, U naught I 2 pi r 3 times 10 to the negative 6 is the current. Mu naught is 4 pi times 10 to the negative 7th. 2 pi, and r, remember, is the distance away from the wire. So 0.02. Okay, that's going to get us our B field. What's the answer? Should be small. .3.0? Okay, is that confirmed? So that would be the magnitude of the B field at that location, okay? And the direction would be, what do we say? Out. So use your right hand rule. Okay? Part 2, or part B, is asking, well, you know, if I just had a proton sitting here in normal life, what would it do? Fall, because gravity is pulling it down, right? So there's a force F sub g trying to bring it down. So if we want it to move in a straight line, then what should be true of the magnetic force? We want it to oppose, right? We want it to go up so that we have this equilibrium state. We have it moving up. Okay, so that should be our FB. Should be our magnetic force should be going up, and our gravitation force should be going down. If we want equilibrium, what should be true about those two? They should equal. So FB should equal FG. Yeah.
What's the magnetic force caused by? Is it just the current through the wire?
No, so the current, so if I just had a proton sitting here, it would actually not be in equilibrium, it would just fall down. So if you remember from kind of one of the first things we did, when you have a proton moving in a magnetic field, there's a force that's going to be exerted on it, okay? And so that force, so if this proton's moving, there's going to be a force exerted on it. Actually, why don't we figure out the direction? Let's figure out the direction right now. So we want the FB to be up. The magnetic field that's coming from this is coming out, right? So we want to figure out the direction of the velocity, what the velocity needs to be in order for that to happen. So we're going to use our first right-hand rule to figure that out. So remember, our palm represents the force. I don't know if this is going to work on this. Our palm should represent the force, right? And we want the B to come out. So my hand should actually look exactly like I just did it. So my fingers are coming out, right? My thumb is therefore pointing in what direction? To the left or to the west. So the direction that the velocity needs to be is this way. And if it's fast enough, or if it's moving at the appropriate speed, then it can create this upward force. Okay? What's the equation to get that upward force? BBQ, and we want it balanced with gravity, so BBQ should be equal to mg. Okay, now we already found the B, and we've done this problem before, Except last time I just gave you the B all by itself. But this time the B is coming from the wire, right? This is what's actually creating the B. Okay, last time maybe it was just a permanent magnet or something. So you can just substitute in the B. So let's do that. So we have 3 times 10 to the negative 11th. V is what we're looking for. Q is a proton. You guys remember the mass on a proton? And hopefully we're not faster than the speed of light. Actually, it doesn't look that fast. How much is it? Kevin, you got it?
345.
345? Is that being confirmed? No?
2.93 times 10 to the negative 4.
Yeah, that's what I thought.
Is that being confirmed?
Yeah.
Okay, good. What would happen if the proton slowed down? Just conceptual questions. If V decreases, what happens to our magnetic force? It also decreases. And therefore, gravity is the same. What happens to the proton? It would start to fall. Yeah. I still see some confusion out there. Is this not being confirmed?
3,409.5.
Yeah.
Great, it had to be on the video, right? That's all right. It's a process, right? So those of you that got it wrong, maybe figure out what you did wrong. Hopefully your names aren't on the video.